a tank in the shape of an invertible right circular cone with height 5 meters and radius 4 meters at the top, filled with hot chocolate. The density of hot chocolate is given by rho equals 1020 kilogram per cubic meter, because this is density. To find the work done to empty the tank by pumping the hot chocolate over the top of the tank. So now let us look at the picture. So this is the picture we have here. In this picture, the height of this cone is given as 5 meters and the radius is 4 meters. So we need to find how much work will be done to pump whole chocolate out of the tank. So in this case, what we will do, we consider a small slice somewhere and then model the question. Let's look at the picture one more time. So it is filled with hot chocolate. So we are considering a small slice here with thickness say delta x. So as you see here, if I consider this length from the slice to the bottom is x meter, the radius of this small slice is r, and then the thickness is delta x. So the volume of this small slice will be, let me call it dv, which will be pi r squared. So pi r squared dx. All right. Now we will take one more information from here. As you see that if you consider like this, this is r, this is 4, this whole length is 5, and this one I call it x here. So using the what do you call similar triangle concept, you can say 4 over, I mean the radius of the bigger triangle over the radius of the smaller triangle will be same as height of the bigger divided by height of the smaller. So in this case, you can find 5r equals 4x, then r will be 4 over 5x, right? That is your r. Now, when you are looking for the mass of this small slice m, so we know mass equals dv times rho, right? And you have now pi r squared dx, and our rho is 1020. And next we are looking at what is the force acting on this small volume. So that force will be now mz. Okay, so then z will be 9.8. So you can write here everything. We have pi r squared dx 1020 times 9.8. So that is the force, and each of this slice will move the distance 5 minus x, right? That you can see from here. So then the total work done will be now integral, and I'm going from 0 to 5. And then we have the force in here, which is pi. What is your r? Now you see it's 4 over 5x will be squared. Then you have 1020. Then you have 9.8 times 5 minus x dx. So this is the whole quantity. Now you need to integrate and find your work done. So I just simplify, bring all the constant outside, and then integral here. So that one is 5x squared minus x to the 3. You can integrate or just put it in your calculator and get it done. So I show you how you do it in the calculator. I am using TI-83 plus, and this one will show me a little different way writing my function. So how you start writing? First, you can put all the constants you have, take them out. 1020 times 16 over 25 times 9.8, and then we have I'm keeping pi outside. Later we'll put pi with our answer, but if you want to approximate, then you can put pi also here. Next you go to math. From math hit 9, that gives you the definite integral concept. As you see here, fn integral, you can just type 9 or scroll down there. After that, you first type your function. My function is x squared times 5 minus x. And then close it, put a comma. Next, you write the variable, which is x, put a comma, then put the limit 0 to 5. 0, comma, 5, close your parenthesis, and then hit enter. So that gives you 333200 pi. So as you see now, that's the answer, 333200 pi joules. If you want to put your pi also in there, you can do that. Let's take your calculator one more time in here and multiply this one with pi. So it's a times pi. Second, this is pi here. Hit enter. So you get 1046778.672 joules. And that's all. Thank you.